Welcome back to 10 out of 10, the show where we interview your favorite scientists. My name is Gloria Borga, and our guest today is Johannes Kepler. So, tell us, Kepler, when you started your studies, what was the state of astronomy? In my time, there were three main orbital theories. The geocentric theory, where the Earth was the center of the universe. The heliocentric theory, where the Sun was the center of the universe. And some even proposed a hybrid theory, a mix between the two. These three theories stated that the orbits were circular with uniform motion. So, what problem were you trying to solve? None of these theories were accurate enough. I wanted to predict Mars' exact position in the sky. To do this, I started working for Tycho Brahe, a fellow astronomer known for having the most accurate planetary observations. With his data, I thought I could solve this in 8 days. Then 5 years passed. Wow. Hundreds, if not thousands of calculations made, and I was ready to give up. However, in just a few days, I started to figure out what was happening. The main issue was my faulty assumption that the orbit's motion was circular and uniform. Instead, after several attempts, I discovered that it's actually elliptical. And from that, I inferred what is now known as my first law. All planets move in ellipses, with the Sun at one focus. But why aren't the orbits circular? Actually, since circles are ellipses, an orbit can be circular. However, that is very unlikely, since it would require that the energy of planets when they were entering the system should perfectly match a highly specific value. And what does your second law state? In any point during the orbit, if you draw an imaginary line from the planet to the Sun, it will sweep out an equal area during an equal time interval. When planets are closer to the Sun, they move faster than when they are further from the Sun, conserving their angular momentum. Your third and last law states that the cube of the semi-major axis of a planet's orbit is proportional to the square of its period. This relation results in a constant which is the same for all planets in the solar system. This relation only holds true when the mass of the planet is negligible compared to the Sun's mass. Sadly, our interview is coming to an end. Are there any closing remarks you would like to say? Authors of scientific breakthroughs are normally depicted as untouchable geniuses with superhuman intelligence to whom discoveries magically came in the form of epiphanies. When in reality, if you take a look at history, it's actually a result of decades of study followed by years of frustrating failures that eventually led to a discovery. Sometimes a failure is actually a step towards success. Thank you for joining us, Kepler, and see you next time.